Now, as I looked at the curriculum, I saw we don't do section 2.3. We actually do section 2.4. So I was going to do this one anyway because I thought that would be good background, but it is going to be one of our required sections. So we're dealing now with linear inequalities. And they're saying properties of inequalities. Generally, when you solve an inequality, everything is the same as when you solve an equation. The major difference, and I'm going to point it out to you right now, if I have the statement 2 is less than 4, that's a true statement. And I think you'd all agree. Now, if I multiply this by a 2 on this side and a 2 on this side, this now becomes 4 is less than 8. And that is still true. But how about if instead of a positive 2, I multiply it by a negative 2? Now I'm doing the same thing to both sides that we do in equations, but now something interesting happens. This becomes a negative 4, and this becomes a negative 8. Now, is this statement true? And the answer is no. So what do we do when we multiply an inequality by a negative? In order to keep it true, we must reverse the inequality sign. So it's when you multiply or divide through by a negative. That's when you have to reverse the inequality sign to keep the statement true. Okay? And that's sort of what they're describing here. So let's take a moment and do this one. So I've written it out to preserve the original. Now, recall when we were doing equations earlier, I said it's always a good thing to try to keep the variable positive. Because if you have a positive variable, then you don't have to multiply or divide by a negative and would have to reverse the inequality sign. So that's the technique I'm going to use. So to keep my variable positive, I'm going to add 3x to this side and 3x to this side. I now get 4 is less than or equal to 7 plus 5x. And now what I'm going to do to isolate the x's on one side, I'm going to subtract 7. And again, I could transpose, but I'm just reviewing some of the techniques. And then this gives me a 5x, and this is going to give me a negative 3. So when I solve for x now, I'm going to divide each side by a positive 5. In so doing, I don't have to reverse the inequality. And if you like to write it with the x on this side, that's fine. Just when you do that, you're going to put the opened n toward the x, and that's a negative 3/5. Now, sometimes they would like you to graph this as well. So on a number line, you see where a negative 3/5 is. And in our system that we're using in this textbook, we're going to put a what there. x is greater than this? And the answer is we're going to put a bracket because this number is included in the set and it goes off towards infinity in that direction. Okay, now let's take a look at it. Here they're giving you the rationale in blue on the right side. Now here they left it as negative. So when they divided, notice this is a less than sign. So when they divided, or in this case multiplied by a negative 1/5, they had to reverse the inequality sign to get the answer. And there's their answer. Again, there's more than one way to do it. I like to keep the variable positive, but they wanted to feature the changing direction of the inequality sign. And there is the graph as well. Now we didn't put it in interval notation, which is something they're showing here. Now, when you go to interval notation and you have the graph, all you do is you take this bracket from your graph, put this point where that is included, put a comma, and where is it going to? What's out here? Well, positive infinity, and infinity, whether it's positive or negative, always uses a parenthesis. Okay, that was a good little one to choose there and look at. Now, in some cases, you're going to be using absolute value. And remember that absolute value, it could have been a negative there as well. And that's as far as we're going on that. So I guess that's about it. And we'll wrap it up. Now, in this section, they didn't give us very many practice items. And I was looking at the practice online, and there are two other examples I thought I might include. So I'm going to include them here. So as we look at this one now, this is a compound inequality. And what would be the strategy for doing this? Well, the strategy would be you want to isolate the x in the middle. So to get rid of this -1, I'm going to add 1 here. But to keep the balance, we add 1 to these other parts as well. So this now becomes a -1. There's our x all by itself now. And then we have 13. So to graph this, we make a line. And usually in your practice and quiz-bees, they give you one already done. So we'll put a line there for -1. And then out here somewhere, there's going to be a 13. Now notice these inequality signs are only less than and less than. So our x is in the middle here. So we're going to use what is called a parenthesis because it doesn't quite start at -1, but just after it. -1 is not in the system. And for this one, it'll be less than this way. And we just darken this line. Now to put that in interval notation, again, right from the graph, we use a parenthesis, -1, comma, 13, parenthesis. And that's how we do one like this. And I have one more to show you. Now, when we do one like this, notice there's a fraction in there. So calling our old techniques of when there's a fraction, multiply everything by the lowest common denominator of 4. And in a sense, this is in a parenthesis due to that division bar, and we multiply this side by 4. So here the 4's cancel out. So this is going to be a negative 12 is less than 2x minus 6 is less than or greater to 20. Notice how much easier it is when you get rid of the fractions. Okay, now we want to isolate the negative 2 first. So we're going to add a 6 here, add a 6 there, and add a 6 there. So this is going to become negative 6 is less than 2x is less than or greater than 26. Now notice we're not dividing by a negative. If this were a negative, we'd have to reverse all these signs. But since it's a positive, we're just going to isolate the x by dividing everything by 2. So this is going to be a negative 3 is less than x, because these cancel out nicely, is less than or equal to 13. Now we make our number line. And the numbers we're interested in is a negative 3 over there and a 13 over there. Now notice this is only a less than sign, so we're going to put a parenthesis here because a negative 3 is not included. But it goes up to a 13. Now a 13 is included. So we're going to use a bracket there, and we just darken in the middle. And putting this into interval notation, we take it right from the graph. Negative 3, comma, 13, bracket. And that gives you a little bit more background on section 2, 4.